All right, so where we're going to pick up from on this part is we're given an equation and it's not in graphing form, but we're going to have to put it in graphing form first before we can do what we have been doing. So that something like this, and I think we've done this before when it's y equals, but we're going to have to use the idea of completing the square. I may have to remind you a little bit on that process, but here's how it works. You're going to look at your two terms that have, in this case, the y squared term and the y term, and you want to create a perfect square out of the two. So you're thinking, scratch work here, y squared minus 6y plus what is going to equal a perfect square. And do you remember how to do this? Okay, what you want to do is you want to take half of this number in front of y, and that would be -3, and so that tells you what the square is going to complete to. And then you're going to take the number that's there, the -3, and square that number, and that tells you what you should have here. So if I have y squared minus 6y plus 9, and I try to factor that, what happens? So I'm looking for two numbers that multiply to 9, add to -6. What are those two numbers? -3, -3. So we formed something that is going to give us the same number here for the product. And so when it factors, you get y minus 3 times another y minus 3, which is y minus 3 squared. That's what we mean. We're completing the square. But the process is back here. You take half of b, half of the -6, to figure out what it's going to square to. And then you take that -3 and square it to figure out what number needs to be added. Once you're there, we get x is equal to y squared minus 6y. I'm going to leave a little extra room, and I want to add in the 9. But when I add a 9 there, the equation is no longer equal to the equation before, and I need to keep it equivalent, and so I'm going to balance that equation by putting in the -9 here. So that if I were to simplify this, it would simplify back to where I started. Question? I'll tell you in a little bit. Okay. So then, after that, we can factor. This becomes y minus 3 squared, and then we're left with -4. And so this is the form that we need it in order to talk about the graph. Okay. So from there, which way is this going to open? If it starts with x equals, it's going to go either left or right. It's going to be along the x-axis. And a is positive, so it opens to the right. Okay. Then our vertex is going to be -4, +3. And I start with the +3 because that's in here, and it's the opposite, and it's telling me it's your y value because it's with the y. So I put the +3 in my y place, and then the -3 fits in the whatever's left over, in this case the x value. I'm going to find out what 1/4a is. Because a is 1, just get 1/4. And that's how, so then I start with my graph here. So -4, +3, there's my vertex. We said it's opening to the right. I'm going to go 1/4 which way to get to my vertex, sorry, my focus. To the right, it's really close to it. I'll put F for focus. My focus is going to be at -4 plus 1/4, 3. If we simplify that, this is, you get a common denominator, we get -16 plus 1, so it's -15/4, 3. That's what your answers would look like if you're checking your answers. All I'm doing is adding those numbers. What else? Axis of symmetry is going to be what? Y equals 3. That's right here. Cuts it in half. And then the directrix is what we said yesterday. The definition of a parabola is that every point on the parabola is the same distance to the focus as it is to the directrix. So in particular, we look at the vertex. And so because the vertex is a fourth from the focus, it's also a fourth from the directrix in the opposite direction. So our directrix is going to be the line x equals -4 minus a fourth, which would be x equals -17/4. So all this right here is from yesterday. Okay. The new part is just getting it into that form. Any questions on that part? On that problem? No, but that's one of the pieces. I want to practice this 2 more times, and then I'll show you a couple of things. Okay, next one. Y equals 1/3 x squared minus 2x minus 4. Okay, so we need to. I want to give you at least a few of these to practice, especially when there's something in front of x squared that's not 1. You know, how do we get it into that right form? So again, this is the part right here, the x squared part and the 1/3 x squared part and the -2x part. That's the part we're going to try to complete the square with. But before you complete the square, we need to make sure you factor out whatever a is in front. So we need to factor 1/3 out. We're not used to factoring fractions out. But when you factor something out, you divide it. So what's 1/3 divided by 1/3? 1. Minus, what's -2 divided by 1/3? Good. So that's what's left. And then this x squared minus 6x, I'll put a little scratch work here. We got to think ahead and think, well, what perfect square would I make with that? So x, what? Well, what would my perfect square be first? -3. So you cut the -6 in half, and then you square the -3 and get +9. So it actually turned out to be the same deal that we had in the last one. So I'm going to add 9 to complete my square. But when I add 9 there, this is no longer equivalent to the expression before it. And I have to keep it equivalent, so I need to balance my equation out. How would we do that? If I put a -9 out here, and if I were to distribute the 1/3 through and simplify it, would I end up back here? Okay, good, -3. So it's really going to be, you got to realize when you put a 9 here, you're really putting 1/3 times 9, which is 3. And so you're going to have to subtract 1/3 times 9, which is to balance that out. So always think, when I put that there, if I were to distribute everything out, would I get back to where I started? If not, then you're not adding and subtracting the right thing. So a is 1/3. X squared minus 6x plus 9 factors to x minus 3 squared. And we have a -4 and a -3, which gives us a -7. And now we have it in the form that we want. Okay. So the 9 inside the parentheses? Or on the outside? Okay, so the 9 on the inside, I am trying to create something that if I were to factor it, would be a perfect square. And a perfect square is both factors are going to be the same. So if I were to factor this, it would be x minus 3 times x minus 3, which is x minus 3 squared. Okay, so that's my goal, because this is the form that we recognize and we can use. To come up with that 9, I take half of the negative 6 to figure out what it's going to factor to, x minus 3 squared. I take the negative 3 and I square it to figure out what that 9 should be. So cut it in half and square it. So that's where that's coming from. This piece is to balance my equation off. All right, because I'm adding something that wasn't there. So 1/3 times 9 is 3, right? So I'm going to have to subtract 3 over here. So that's what we're going to practice it again, but that's where it's coming from. So which way is this going to open? Starts with y equals, so it opens either up or down, and then a is positive, so that tells us it's opening up. And what's our vertex? 3, negative 7, okay? And so if I were to sketch this, here's 3, 7, opens up. My focus is going to be inside, and what would 1 over 4 times a be in this case? 1 over 4 times a third, which is 1 over 4/3, which is 3/4. Okay, so that tells me I need to move up 3/4 from the vertex to get to my focus. So the focus is going to be, I was at a height of negative 7, and I went up from there 3/4. What would that be if I added negative 7 and 3/4? Yeah, but what would it be? It's not hard to do. So it's negative 7 times 4 plus 3. Okay. Axis of symmetry is going to be x equals 3. And then the directrix is going to be y equals, the height of the vertex is negative 7, and I went down from there 3/4. And if I clean that up a little bit, that would be negative 31 over 4. Right. So again, new part is getting into the right form, and then yesterday, which is still new for us, getting these pieces here. One more like this. This time I'll let you work ahead of me. Try this one. X equals 15y minus 3y squared minus 16. I want you to graph that and find all those pieces. All right, so hopefully you caught that it wasn't in order, and you rearrange the order. You put the negative 3y squared first, plus 15y minus 16. That would be your first step. Second step, if a is not 1, you're going to want to factor it out of the terms that have the variable. So in this case, our variable would be y, and we're going to factor a negative 3 out. What's left? Y squared minus 5y. Leave a little space to complete the square, put a minus 16 out here. So scratch work over here, I'm going to take the, okay, so y squared minus 5y. I need to figure out what to add so that I get a perfect square. In this process, I'm going to take half of that -5, which would be 5 over 2. And I'm going to take that -5 over 2 and square it, and that gives me 25 over 4. So 25 over 4 is what I need to add to this piece so that it would factor to a perfect square. You guys have done this before, right? It's been a while. Add 25 over 4. Now if I add that 25 over 4, now it's not balanced, right? So I need to figure out what to put over here to balance this out. So its real value is -3 times 25 over 4, which is -75 over 4. So I need to add 75 over 4, balance that out. So that if I were to multiply stuff out, that would cancel out. Okay. When it factors to y minus 5 over 2 squared. And in this piece here, this is 16 over 1, which is the same thing as what? -64 over 4. So -64 plus 75, 11 over 4. So this is the form we want it in. And now we can talk about its graph. Which way does it open? Starts with x equals, so left or right. A is negative, so the negative x direction would be left. What's my vertex? (11 over 4 and +5 over 2. So 11 over 4, 4 goes into 11 2 times, so this is 2 3/4, right? And 2 goes into 5 2 times, so this is 2.5. So we go right 2.5, up 2 3/4. About right there. Opens to the left. I got to find 1 over 4a, which would be -1/12. So my focus will be -1/12 to the left. My directrix will be -1 or +1/12 to the right. And if we subtract that, get a common denominator, which would be 12, you get 32 over 12. You can reduce that. You could divide by 4 and get, what, 8 over 8/3. Okay, so that's our focus. Directrix is x equals 11/4 plus 1/12. Is 17 over 6. And what's our axis of symmetry? Y equals 5 over 2. Okay. All right, so there's 3 examples where we had to get it into the right form first and then find the pieces. Question? Okay. I want to look at a couple different types of examples now. And this is working backwards. I'm going to tell you some things about the graph, and you got to write the equation. So I'm going to tell you the focus is 5, 1. The directrix is x equals -1. And I want you to come up with the equation that would have that. And there's only one equation that has this. And so when you do this, you want to start with a picture so you can visualize what's here. So 5, 1. That's my focus. Here's my directrix. Okay. And when you write an equation, you need 3 things. Okay. If you can answer these 3 things, you can write an equation. So first thing is, which way does it open? Second question you need to answer is, what's the vertex? And third question you need to answer is, what is A? If you can find all 3 of those things, then you can put it together and write your equation. So the vertex is going to be right in between the focus and the directrix. And we have the focus and the directrix, so where would that vertex be? Right there? 2, 1? Well, let's check. If you're at 2, 1, then you're a distance of 3 from your directrix. You're a distance also of 3 from your focus, so it is going to be lined up, and it's right in between. So we got our vertex at 2, 1. Which way is this going to open? It always opens towards the focus. So it opens to the right. And then the next thing we need to figure out is, what is A? Now we know that 1 over 4A is equal to the distance from the vertex to the focus. And we can count that. What's our distance from the vertex to the focus? 3. Okay? And so from this, we can solve for A. So multiply both sides by 4A, and I get 1 is equal to 12A. And then divide by 12, and you get A is 1/12. So then you put those 3 things together. So should this be x equals or y equals for my equation? X equals. Should A be positive or negative? It's opening to the right. And then I'm going to have y with something in here. What will be with it? -1, the y value, plus 2, and now I have our equation. That's working backwards from the graph to the equation. I want to go over one more example with you, but before, yeah, go ahead. How did I solve for A? So remember our formula 1 over 4A? Usually we don't know how far our vertex is from our focus, and so we know A, so we plug it in to find our distance. Here we know the distance, so we can use that to find our A. All right, before we do the next one, I need to teach you one more thing. So here's our parabola. Focus is inside here somewhere. Directrix is over here. And if you draw a chord is like a line segment that's parallel to your directrix through the focus with its endpoints on the parabola. So I'm going to draw that right here. So this chord right here, from point A to point B, we call that the focal chord. So AB is called focal chord. So again, it has to be parallel to the directrix, and it has to pass through the focus. Okay, and its endpoints are on the parabola. Now it's not drawn to scale, but I'm going to, from point B, I'm going to draw a perpendicular to the directrix. And I'm going to call that point C. What's the definition of a parabola from yesterday? It's the set of all points, including B, that is this, and B is the same distance to F as it is to C. That doesn't look like it. That's why I said it's not drawn to scale. I probably have to redraw it, but by definition, that's what that means. Okay, so the distance from F to B is the same distance from B to C. You okay with that? All right, that's it from the definition. Now here's my vertex, point V. I gave you a formula from F to V. What's that distance from the formula? 1 over 4a. Okay. I also told you that's the distance from V to your directrix. That's also 1 over 4a. So can anybody tell me what the distance is from B to C? It's 1 over 4a plus 1 over 4a. Does that make sense? Because this is 1 over 4a and this is 1 over 4a. So you add them up to get that total distance, which is 2 over 4a, which is 1 over 2a. What else is 1 over 2a? The distance from F to B. That's the definition. Because the distance, if you pick any point on your parabola, the distance from that point to the focus is the same as the distance from that point to the directrix. You following what I'm saying? But this is in the middle, so what do you think the distance from A to F is? So what's the distance from A to B? What is it? Not A. No. 1 over 2a plus 1 over 2a is 2 over 2a, 1 over a. All right. So we need to know this, that the distance of the focal chord, your focal chord distance, is always 1 over a. Okay? So you'll need that for this next problem. And this will be the last problem. These are the clues. And we need to, the goal is to write the equation again. Okay? Whenever you write an equation, you still need to find those three things. You know, which way does it open? What's the vertex? And what is A? That's all you need. Once you have those three things, you can skip whatever work you need to do and jump right to your equation. Okay, so those are the three things you're always keeping in mind. So now we're given focal chord endpoints. That would be like me giving you A and B in that picture. So I give you those focal chord endpoints, and I'm telling you A is positive. And that's all I'm giving you. So again, start with a picture and see what you can make of it. So negative 3, 2. That's a focal chord endpoint. And 1, 2 is a focal chord endpoint. And A is positive. So if you have your two focal chord endpoints, what else do you know for sure? The focus is right in between, right? Where's the focus going to be? So there's our, I'll label with an F. There's our focus. Which way is this parabola opening? Up? Okay. So I know one of the three things I need. It opens up. But I need two more things. I need the vertex, and I need A. A is actually not going to be hard. How can we find A here? Okay, we know the focal chord distance is this distance here, which is 4. And in general, that's equal to 1 over A. And that's what we just went over. That 1 over A is the distance of your focal chord. And so what's A going to be? A is 1/4. Okay. So how can we get to our vertex now? Do you remember how to find, if you know what A is? 1 over 4A is the distance from the focus to the vertex. So what's 1 over 4A? Okay. So from my focus, I need to drop down 1. So where is that? That's my vertex at negative 1, 1. So once you have those three things, stop working with your graph and write your equation. So it opens up. So is it x equals or is it y equals? Y equals. Should A be positive or negative? And then x, what happens now? Plus 1, we're taking the opposite of my x value, squared, plus 1, have my equation, we're done. Okay. Your homework is going to be worksheet 2, just the odd problems, Michael. Okay? All right. Just the odd problems.